Welcome to my channel. Today's tutorial is on polymorphism. We will delve into the fascinating concept of polymorphism and understand how it enhances the flexibility and extensibility of our code. Concept that stands out for its versatility and flexibility is polymorphism. Polymorphism allows us to write elegant and extensible code by treating objects of different classes as interchangeable entities. Polymorphism refers to the ability of an object to take on multiple forms. In polymorphism, objects of different classes can be treated as objects of a common superclass. It allows objects of different classes to be accessed and manipulated through a common interface, enabling code reuse and extensibility. There are two main types of polymorphism: compile-time polymorphism and runtime polymorphism. Compile-time polymorphism is achieved through method overloading and operator overloading. Method overloading involves defining multiple methods with the same name but different parameter lists, allowing the compiler to determine the appropriate method to execute based on the arguments provided. Operator overloading, on the other hand, allows operators to behave differently depending on the types of operands involved. On the other hand, runtime polymorphism is achieved through method overriding and is closely tied to inheritance. Method overriding enables a subclass to provide a different implementation of a method that is already defined in its superclass. During runtime, the method to be executed is determined by the actual type of the object rather than its reference type, allowing for dynamic and flexible behavior. To illustrate the power of polymorphism, consider a scenario involving various animal classes inheriting from a common animal superclass. Each animal class implements its own version of a make sound method. By treating objects of different animal classes as instances of the base animal class, we can write generic code that operates on any animal object without knowing its specific type. This makes it easier to add new animals to the system without modifying the existing code. Let's go through C++ example of polymorphism. In this example, we have a base class shape with a virtual function draw. The virtual keyword is used to indicate that this function can be overridden by derived classes. We then define two derived classes, circle and square, which both override the draw function with their own implementations. In the main function, we create objects of the derived classes, circle and square. We also declare a pointer shape ptr of type shape, which can point to objects of the base class or its derived classes. We assign the address of the circle object to shape ptr and call the draw function. Since the draw function is marked as virtual in the base class and overridden in the circle class, the appropriate draw function for a circle is called. Next, we assign the address of the square object to shape ptr and call the draw function again. This time, the draw function for a square is called. In the above example, the calculator class has multiple add methods with different parameter lists. The first add method accepts two integers, the second add method accepts two doubles, and the third add method accepts three integers. In the main function, we create an instance of the calculator class and call the add methods with different arguments. The compiler determines which version of the add method to invoke based on the number and types of the arguments provided. When the program is compiled, the compiler resolves the method calls based on the provided arguments. In this way, the appropriate method is selected at compile time, and the correct addition operation is performed accordingly. In this example, we have a base class called shape, and 3 derived classes, circle, rectangle, and triangle, that inherit from the base class. The draw method is declared as virtual in the base class and overridden in each derived class. Inside the main function, we create objects of the derived classes and assign them to pointers of type shape. When the draw method is called on each object, the appropriate version of the method is executed based on the actual type of the object. At runtime, dynamic binding takes place, allowing the correct implementation of draw to be executed based on the object's type. This is an example of runtime polymorphism, where the decision on which method to call is made during runtime based on the actual object's type, rather than the reference or pointer type. Polymorphism is a crucial concept in object-oriented programming that empowers developers to write flexible, scalable, and maintainable code. By leveraging the ability of objects to take on multiple forms, polymorphism promotes code reuse, simplifies maintenance, and enhances the overall modularity of applications. Understanding and utilizing polymorphism effectively allows developers to unlock the true potential of OOP, enabling the creation of robust and extensible software solutions. That's it about polymorphism. I hope you found this tutorial informative. Feel free to leave any questions or comments below, and don't forget to like and subscribe for more programming content. Thank you.